Hey everybody, it's Miles. I'm back again with another algorithm set. This time we're going to be looking at best time to buy and sell stock. I quite like this one because there's so many approaches to go with it. We'll actually look at two different approaches going through an iterative fashion. But there's you could do so much with it. That's why it's so interesting. And I also like the boundaries that it puts on you. So let's look at the questions over here, or the prompt, I should say. So you have an array which the ith element is the price of a given stock on day I. If you were only permitted to complete one transaction, right? There's another version of this problem where you can complete multiple. But if you're only allowed to permitted to do one, design an algorithm to find the maximum profit. And you cannot sell a stock before you buy one. So I like to think of this as like days of the week, right? So this would be Monday. We buy our stock for $7. And then if we bought it for $7, it's going to be tough for us to sell it because all of these prices are way below it, right? So the optimal time to buy it, you would say, is at the lowest price, so on 1. But you can't go back and sell in the past, right? If I'm on Tuesday, how can I sell at Monday's price? So then here you have to go through and find the biggest difference. So we'd say 6, right? So it's 6 minus 1, max difference is 5. And then if there is none, then it's 0. So let's start off by setting this up. So the first thing we want to do is think about our return variable, right? We would say that what we're looking for here, right, is the max profit. So we can easily just call it that, max profit. Set that equal to 0, because in the case that we don't actually are able to return anything, see all these numbers are higher than each other in ascending order, we would want 0, so that sets us up well. And then our next thing that we can do here, if we think about how we're starting here, an easy way to do this is to think of our portfolio, right? We're acquiring stocks and we're looking back and we're checking. So one thing we can do is we can say let owned stocks, right? You could equal an empty array, but I think it's actually better and uses less space and is quicker if I started off with stock prices, our argument here, of 0, right? So I have stock prices of 0 set here, so I'm already starting at one stock. That signifies to me, and you probably would know, that we're going to say let I equal 1, right? Because we're already starting at our stock right here that we're going to compare off of. So as long as I is less than stock prices dot length I plus plus. Okay. So now inside of our for loop, the next thing we want to do is we want to find our difference, right? Because essentially what we want to figure out is if that difference is bigger than the max profit, that's what we want to set it equal to. So what we can do is we can say let diff equal stock prices of I minus math.min of our own stocks array. So since it's an array and we're doing a min on it, we would actually have to do it like this, right? So now what we're taking here is we're finding the difference between our current one, so at 7, and the minimum here. So that difference for this, what is going to be 7, that's not going to be bigger than our max profit. So if we go here, if we say, I'm sorry, I misspoke. I meant that it's going to be bigger than our max profit. So what we'll put here is we'll say if the diff is greater than the max profit, all right, then we want to set the max profit equal to the diff, right? And then the next thing we're going to do here, and I'm just going to kind of keep going, is we're also going to take our array and push the stocks into it. So we're going to say own stocks dot push. Can't spell today. Stock prices of I. Okay. So now when we're going through here, and let's just do one more thing just to finish the thought. We're going to return the max profit. So we go through our array, right? We're iterating through stock prices, what we're giving as our argument array. We have a difference here where we take the stock prices of I minus the math.min of own stock. So right now this is going to be 7, and then we're on 1, right? So 1 minus 7, that difference is not going to be greater than 0, right? So then we're going to move forward, and then now we've pushed in that 1, all right? So now we're looking at the next version in here. When we look back at math.min of owned stocks, 1 minus 1, so on. So now if we run this code, oh, I'm sorry, I missed a spread right here. There we go. Perfect. Cool, and then let's submit that. Right, not very fast, uses a lot of space. So I think this one actually explains it pretty well, pretty clearly as to what you're doing, right? You start off with one stock, and then you're taking the minimum from there, and then you're pushing in, you're constantly getting the minimum, and then you're subtracting from that day, and that's the biggest difference. If it's greater than the max profit, then you set it equal to. But I think there's actually a quicker way to do this as well, and it allows us to move through the array in, or, not going to sugarcoat it, we go backwards through it. So let's remove this, and let's put here, we'll have our stock max, set that equal to 0, and then we're going to have a max diff. Okay. So the big difference here is, since we're comparing the numbers against each other, what we can actually do, and we have to do it in a linear fashion, is we can actually go backwards. So what I mean by that is we'll say let I equal the stock prices dot length, right? As long as I is going to be greater than or equal to 0, I minus minus. So let me take you through that really quickly. So what we're doing, instead of setting I equal to 0, we actually set it to stock prices dot length, which I believe would be 5 if it's the days of the week. We can double check the, yeah, so right here. It's actually 6. Okay. So then here, the next step is you say as long as I is greater than 0, greater than or equal to, that's important because it needs to be set to, actually, I think if we do minus 1 here, that'll make more sense. So now when I subtract from that length, as long as it's greater than or equal to 0, it'll cover all of our elements. And then simply what we can do here is let's make the stock max and set it equal to math.max of prices of I, and then stock max. So this is just the standard format for setting up a math.max function. So I have the two things that I'm looking to get the max out of. So this is either going to give me prices of I or stock max, depending on which is bigger. And then, as you might guess here, our next thing is to be max diff. So for max diff, what we're going to say, it's math.max of max diff. I really can't type today. And stock prices of I minus, oh, actually, I think I got that backwards. Sorry. Here we go. It's max diff, and then stock max, here we go, minus stock prices of I. Perfect. And then we're going to go ahead and return max diff. Okay, so if we look at it, let's run it and see if this works first. Let's see here. Prices is not defined. Oh, I see what I was doing. I was writing prices instead of stock prices. Always good to check. So let's run that again. Cool. So what we did this time around is a little bit different, and it allows us to kind of change what we're working with in a sense. We're not actually literally changing anything, but it's the way that we're looking at it through a scope. So when I'm going through my array backwards, because I'm doing that, I know that I'm still working through it in a linear fashion, and I can actually play with the stock max in a different way. Because if I go back to the description here, right, if I'm going backwards, I know that my max value, I can do it in a way where I'm taking the max difference, that I don't have to attribute or count for days being higher in the past, if that makes sense. So here, I can actually take the max and then just take the max diff from here, since I am going backwards, and then return that max diff. And there you go, much faster, right? I think if we even submit again, we might even get it to go even faster. Oh, no. But still, I find this solution much better. That was my explanation for max profit. Let me know what you think, and that's it.